This is Chapter 5, Study Sheet, going over the relationships in triangles. And we're going to go over a lot of the theorems and pretty quickly. So if you need to pause at any time to write down anything, make sure you do that. So the first one we're going to talk about is the perpendicular bisector theorem. And in the perpendicular bisector theorem, we have, and I'm going to go over here because I switched up the pictures, we have that that CD is the perpendicular bisector. So it makes a right angle and it goes through the midpoint. So we can assume, because of the perpendicular bisector theorem, that AC equals BC. So that's what we can assume. We can set those two equal to each other to solve. That is the perpendicular bisector theorem. Now, the converse of that is just flipping that around. Since we know that AC and BC are equal because they're both 8, then I know that point C is on the perpendicular bisector. You can think of that as an isosceles triangle. All right, the next one, the circumcenter theorem, and this again is talking about perpendicular bisectors. So we will have 3 perpendicular bisectors, and this is in our big triangle. So think about this being in a triangle, not necessarily like what we were talking about up here. Remember, the circumcenter is all 3 of those perpendicular bisectors meeting together at the point called the circumcenter. And so we know to solve for, we see the circumcenter, all segments from the circumcenter to the vertices are equal. Circumcenter to vertices, which means that's the hypotenuse of those little baby right triangles in that big triangle. And if you see the circumcenter, you can use a squared plus b squared equals c squared to find a missing side length. We're going to move on to angle bisectors. So the angle bisector theorem, we will have the angle bisector. So we'll have 2 congruent angles. What will that give us? That will give us that point D is equidistant and perpendicular to the sides of the triangle. So I know that I can set AD equal to CD. Remember, it has to be perpendicular and equidistant. Now the converse of that, we have to have 2 things, and we talked about this in class. We have to have that AD is equidistant to, or is congruent to CD. We also have to have that those segments from D to the side of the angle are right angles. From there, I can now know that I have 2 congruent angles. So you have to have both. You have to have both perpendicular and congruent to have an angle bisector. All right, the in-center theorem, this is when we are kind of putting all 3 of those angle bisectors in one big triangle. So we have angle bisectors at each vertex of a triangle. So I know that this one's congruent to that one. That one is congruent to that one. Those 2 are congruent. So what can I solve for? Now I know that the segments from the in-center, which is point G, to the sides are congruent. So I know that DG is equal to GE, which is equal to GF. That is very important because then again, notice your baby right triangles in the big triangle. You can use the Pythagorean theorem. All right, some of the questions over your test are not going to come out and say that you have angle bisectors. So you might see a question phrased in these 3 ways. The first one, Point J is the incenter. Well, if point J is the incenter, I have to know that I'm dealing with angle bisectors, and I also have to remember, like up here, that the segments perpendicular to the sides are the ones that are congruent. So I have to know that how the connection works. Another question might say, point P is the centroid. Well, centroid to me tells me medians, which to me tells me I need to multiply segments by 2/3, 1/3, or multiply it by 2. And we'll talk about that in a little bit. And then another way it might say is point K is the circumcenter. Well, circumcenter tells me perpendicular bisectors, which we talked about up top. Those segments to the angles or vertices are the ones that are congruent. So you need to make sure you make that connection. Another theorem that we have talked about is called the centroid theorem. Centroid, remember, goes with medians. And these are the 3 equations we have to make sure we know and use. So if I'm dealing with the whole median, I'm going to say the big part of my median. Remember, the big part is from the vertex to the centroid. So the big part equals 2/3 the whole length of the median. Or if I have the small part, which is the centroid to the side of the triangle, I'm going to say the small part equals 1/3 of the whole median. Now, another way we have also used this is using it with the parts of the median. So that's if I have the small part and the big part, but I'm not necessarily dealing with the whole. You can say the big part equals 2 times the small part. So make sure you remember all 3 of those equations. Those are very important. All right, on the back, let's move down to writing the measurements of the triangles. Right down here. We'll skip over the altitudes. From least to greatest. Remember, least means smallest. Greatest means largest. So when I'm looking at this triangle ABC, triangle number 1, I'm looking for the shortest side. Well, 4 is the shortest, so that's where I get AC. And I know that the angle opposite that, angle B, will now be the smallest. Next, I need to go to the medium. So 4.5 or 4.25. Well, I know 4.25 is the next smallest. So BC or CB would be my next side. Across from angle A would be my medium angle. And then last, AB is the biggest side. So that goes last across from angle C. That is my next biggest. You might have a triangle like number 2, and you can go ahead and look at that one. Just as a reminder, the smallest angle is opposite the smallest side, so you need to do small, medium, and large. All right, another problem you will have to do is describe the possible lengths of the third side of the triangle. Remember, this means find the range. So I'm given 2 lengths. Remember, you always have to have 2 answers. You have to have that inequality statement. So I'm going to say 4 plus 8 has to be greater than x. And then I'm just going to rotate them. 8 plus x is greater than 4, and x plus 4 is greater than 8. I'm going to solve. I would get 3 different answers, but remember, I can't have a negative. So I'm going to take that one out. So I'm going to use this one, and I'm going to set it up into an inequality that looks like that. X has to be less or greater than 4, but less than 12. Triangle inequality theorem is just asking yourself, can I make a triangle out of these 3 measures? So my first one is 3, 6, and 9. So I'm going to say my small plus my medium Does that equal my large? If that is a yes, then it's a triangle. If it's no, it's not a triangle. So 3 plus 6, is that greater than 9? So I get 9 is greater than 9. Well, 9 equals 9, so it can't be greater. So that is a no, so it's not a triangle. All right, in the next one, you can see 11 plus 14 is greater than 21. Well, is 25 greater than 21? Yes, so that makes a triangle. All right, the hinge theorem we talked about in class today again. Hinge meaning the angle part of the door. That's how I remember the difference between hinge and the converse. So you do need two congruent pairs of sides. So I have that is congruent to that on two triangles. Remember, the hinge and the converse is talking about or comparing two triangles. So I have two congruent sides and the included angle. So I have the included angle in the hinge. I'm going to solve for the opposite sides. Again, hinge is solving for the opposite sides. So because 111 is greater than 108, I know the side opposite 111, which is TU, is greater than the side opposite 108, which is RS. Now the converse of the hinge is just the opposite. I need two pairs of congruent sides again, but now I'm given the third side. So notice I'm given 12 and I'm given 13 because I have two pairs of congruent sides. So I'm going to look. I have 13 and I have 11. Well, I know 13 is greater than 11. So I'm going to look across that 13 to angle 2. So I know angle 2 is greater than, because 13 is greater than 12, measure of angle 2 is greater than the measure of angle 1. Indirect proofs, remember, I'm going to start out with my assumption, and my assumption is just the opposite of my prove statement. That's where I'm going to start. I'm going to have the end in mind, so I'm going to figure out the opposite of my given, which is my finished product. This is what I am trying, some of my words got cut off, trying to get to. We are trying to reach our contradiction. So I would go back over some of those indirect proofs and look to see what you might need to practice more of or review or kind of find those patterns. The last thing is the exterior angle inequality. So we know because 1 is the exterior angle, we know that 1 is greater than the remote interior angle. So 1 is greater than x and 1 is greater than y. A couple things on the altitude. Make sure you know the altitude is also considered the height. All right, that is all I have for Chapter 5 study sheet. If you have any questions, please let me know. Have a good night.